Shalom IT lovers of my classes, welcome to Easy Machine Learning number 2 with Python on Google Colab. Of course, you are invited to watch my previous tutorials, particularly the last week one, if you want to follow along here. We started another classic machine learning practice project called Titanic. For that, we are using the Gaussian Naive Bayes Algorithm to predict whether a passenger survived or not based on features like age, gender, ticket, class, etc. We already imported the necessary libraries and packages. We loaded the dataset and printed it. Today, after the inspection of this dataset, we will drop some columns and convert others using the LabelEncoder. Then we will pre-process and split the dataset into features and target, and also into training and testing sets. Then the last part of this project will come next. Thank God again, I'm about to tell you the same thing in German and French. Wir haben ein weiteres Machine Learning klassisches Übungsprojekt namens Titanic angefangen. Dazu verwenden wir den Gaussian Naive Bayes Algorithmus, um anhand von Merkmalen wie Alter, Geschlecht, Ticket, Klasse und so weiter vorherzusagen, ob ein Passagier überlebt hat oder nicht. Wir haben bereits die notwendigen Bibliotheken und Pakete importiert, den Datensatz geladen und ausgedruckt. Heute, nach der Inspektion dieses Datensatzes, werden wir einige Spalten löschen und andere mit dem LabelEncoder konvertieren. Dann werden wir den Datensatz vorverarbeiten und in Merkmale und Ziele sowie in Trainings- und Testsätze aufteilen. Der letzte Teil dieses Projekts wird dann nächstes Mal passieren. Gott sei Dank erzähle ich euch wieder das Gleiche auf Französisch. Nous avons lancé un autre projet machine learning classique appelé le Titanic. Pour cela, nous utilisons l'algorithme Naive Bayes gaussien pour prédire si un passager a survécu ou non en fonction de caractéristiques telles que l'âge, le sexe, la classe du billet, etc. Nous avons déjà importé les bibliothèques et les paquets nécessaires. Nous avons trouvé les données en ligne et nous les avons imprimées. Donc aujourd'hui, après l'inspection de ces données, nous allons supprimer certaines colonnes et en convertir d'autres à l'aide du LabelEncoder. Ensuite, nous pré-traiterons et diviserons l'ensemble de données en différentes catégories. On va voir. Enfin, la dernière partie de ce projet.
Move on. This is where we stopped last time. We did this part first on the first window, and then we moved on with this part until here where we printed the data. I can scroll down so you can remember what we saw last week. The 891 rows multiplied with 12 columns. These are the Titanic data. Okay, so let's scroll back to the top here. So right after print Titanic data, we want to insert our next comment. It's going to be inspect. The data set to identify columns with the non-numeric values. 4 columns in Titanic. And here we have a suggestion. I'm going to take this one and dot column data. Here we want to insert the column. And here we print we want to drop the column that are not useful for prediction. So Titanic data. Let's choose it right here. And then here we want to drop, which is, the drop now function of ML. So we're going to drop the name and let's drop also the ticket. I think it's not really relevant. And the cabin. Now we can get this axis here equal 1 and in place. It's going to be true. All right. And here we want to handle the missing values. And now this time we want to fill now. First there is this drop now and then the fill now method. We gotta put it like this, double F, fill. And here we want to encode categorical variables. So here we want our LabelEncoder. We encode the categorical variables with our LabelEncoder, and we call it sex here just like they did on the dataset, not gender. And here LabelEncoder again. We want to fit and transform we gotta indicate again Titanic, and we are talking about the gender here, so we get it here again, and we're good. So next is going to be the town, and this time we want the embarked. Equal LabelEncoder dot fit transform the same, and this time we have to indicate Titanic data in square. We want our embarked. Yes. So as you can see, we dropped the name, ticket, and cabin columns, as they may not directly contribute to the prediction of survival. Then we encoded the sex and embarked columns using this LabelEncoder to convert categorical values into numeric ones. Right now we want to split our dataset into features and target variables. So let's comment this one, so we always keep track on what we are doing. Split the data set into we say training, and this is always the same pattern. Okay, first X and then Y. X Titanic data, now we're gonna say here drop survived axis equal 1, Then it's going to be y equal Titanic data, and all we want to get here is survived. Yeah. This is now that we are on training and testing set. Here was the features, the features and target variable, here. Okay, this is now I was like, am I going to do it twice? It's here that we are going to split the data set into training and testing sets. Okay, first the features and the target, of course, with X and Y. And now for the splitting of the data set into training and testing sets, it's also, always the same pattern too. And then X test. Now we want our Y train. And Y test. And here equal train test split. And then we have to indicate X, comma Y, comma test. Size is going to be equal to 0.2 random state. Here I get 42. Okay, we are good. So we still have our data, so it's not necessary to run the part which is performed right now. It's going, nothing's going to happen, I mean, nothing more than last time, but we are advancing, and next time is going to be the last part. So today we inspected the data set, and we dropped the columns, handled the missing values, we encoded the categorical variables, and we split the data set into features and target, and into training and testing sets. All right, next time, God's willing, we want to initialize the naive Bayes classifier, train the model, make predictions on the test data, etc. And then we can run and see the final part, the accuracy of the model. Bye-bye. God bless you.